two examples, examples 4 and 5 from notes 5.1 day 2 on compound interest. And in class, we derived the number e. Remember that e is a transcendental number. That means it's a number like pi, which is a decimal that neither repeats nor terminates. It's approximated at 2.718. Here's a longer approximation. And we can treat it just like any other number, just like pi or any number that we like. If we have continuously compounded interest, that's a special application. In this case, we have to use the number e. And here's the formula. A equals P times e to the RT. A is the amount of money in the account at the end of the period of time. So amount of money in account at end of T years. P, this is the amount of money you initially invest. So that's called the principal. So the amount of money initially invested. E is the number E, 2.718. R is the interest rate expressed as a decimal. And it's an interest on an annual basis, so like 3% per year, something like that. And T is going to be the time in years. Okay, so I'll squeeze that in up here. T is the time in years. So let's try example 4. Example 4 says, if you invest $3,500 at 3% annual interest, compounded continuously. When you see compounded continuously, you're going to want to use this formula, A equals P times e to the RT. This is sometimes abbreviated as PERT. So you can think of it as PERT. So you're going to want to use the PERT formula when you see compounded continuously. That's the trigger that tells you which of the formulas to use. How much is in the account at the end of 4 years? So we're going to use A equals P times e to the RT, and let's substitute in what we know. $3,500. 35 is the principal, the amount you initially invest. So $3,500. E is the number E. We've got 3% right here. This is the interest rate. So R is equal to 0.03. Because it's an annual interest rate, we want to express it as a decimal. So 0.03. And it says you're going to hold that investment for 4 years. So that means T is equal to 4. So we're going to have 0.03 times 4 in the exponent here. And if we calculate this, we can figure out how much money we'll have in the account. So let's pull over the calculator and we'll enter it in. So we have $3,500 times, I can use this e to the x button right here, e to the x, and then I'll put in 0.03, the interest rate, times 4, and hit enter, and that'll give us our solution to this problem. Another way to enter this would be to use the number e, which is located on the pi key. So I can hit e, 3,500, and then I'll have to use the exponential function button, which is this little caret, then 0.03 times 4. Either way is fine. In both cases, we get our solution, which is 39.4624. Since it's money, we'll round to the nearest hundredth or the nearest cent. So we'll put our answer down here. A, the amount of money we have is going to be $3,946.24 after 4 years. Let's go on to example 5. In example 5, we're asked to determine the amount of money that should be invested at 9% interest compounded monthly to produce a final balance of $30,000 in 15 years. So here the interest is compounded monthly. We cannot use the continuously compounded interest formula here. So we can't use PERT. We have to go back to our previous formula, which was the amount of money that you have is going to be equal to the principal, the amount you initially invest, times 1 plus R over N, where R is the interest rate on an annual basis expressed as a decimal, divided by N, the number of compounding number of times the interest is compounded per period, raised to the n times t, where t is the time in years. So let's identify the data that we have in this problem. So we want to know the amount of money. That's the amount of money that should be invested. So we want to find P at 9% interest compounded monthly. So that means R is equal to 0.09. Remember, you always have to express the interest rate as a decimal. Compounded monthly. If something's compounded monthly, that means it's compounded 12 times per year. So N is 12. To produce a final balance of $30,000, that means A is equal to 30,000. And it says in 15 years right here. So that means that T is going to be 15. Let's substitute these things into our formula. So we've got 30,000 is equal to P. That's what we want to solve for. Times 1 plus R, which is 0.09 over 12, raised to the n, 12 times t, which is 15. This looks a little bit complicated, but all of this part is just a number. So if we want to isolate p, we can divide both sides of our equation by that complicated expression. So we'll get 30,000 divided by 1 plus 0.09 over 12 to the 12 times 15 is equal to P. And our calculator doesn't mind if we enter it in that format. So let's go ahead and do that. So I'll bring up my calculator and I will enter in the expression that we would like to calculate. So it's going to be, I'll do control divide, so it's a little bit easier to enter. 30,000 divided by, I need parentheses here. So I'll put inside parentheses 1 plus, control divide to get another division symbol in math type, 0.09 divided by 12. And now I need to raise all of that, so I'll use the caret. I'll put parentheses, and I need 12 times 15. And if I hit enter, I find out that the amount of money we need to invest is $7,816 and 48 cents, rounding to the nearest cent. So I'll solve this. So P turns out to be equal to 78.1648. So that's how much money we need to invest at 9% annual interest when it's compounded monthly over a 15-year time period to end up with $30,000.